Due today, Lauren, is Connect Math 7.3. I think you might need to know how to find means and standard deviations on your calculator in order to do that. So we'll go over that. And then Thursday you have Connect Math 8.1, 8.4 due. And also Excel Lab 7 is due. You can turn that in late for full credit, though, until next Thursday. This Thursday, you can turn Lab 5 in late for full credit if you haven't turned it in already. After that, you'll lose 10% for each week that's late. Monday, you have Connect Math 8.3 due, and then next Tuesday, we'll start in on Chapter 9 material being due. So before I forget, let's hop in and take a look at how to find means and standard deviations for a list of numbers. So far, now you have proven to me you know how to find, given a list of numbers, how to find the mean and standard deviation. So now you can just use the calculator to do it. So I think we did it once before, but I'll refresh you in case you've forgotten. We're going to go to Stat, Edit, so Stat, Edit, and then just type your numbers in whatever they are, 25, 36, 41, 28. Just type them into this first list here. And then go to Stat, Calc, 1-bar stats. Now just put in list 1, the list that you have your data in. Don't do comma list 2, just list 1. So second 1 will give me L1, enter, and there gives me my mean and my standard deviation. You notice it gives you S and sigma because the calculator doesn't know whether you gave it the whole population or just a sample. You know you gave it just a sample. Right, so you know which one to use. You know you need to use Sx and not sigma x, because Sx is the one that's valid, not sigma for a sample. All right, so that's how you do that. You're going to need to know how to do that for the homework 7.3 and also for 8.3 as well. So if we give you a list of numbers, we expect you to find the mean and the standard deviation of them. All right, other thing too is make sure everyone's wearing their masks. Right, we can't afford to have anybody down the next week. We have 2 weeks before we hit our test before Thanksgiving, and you folks don't want to be sick before that. Right? It will not be good for your grade. Okay. And even if you are vaccinated, I had a student who got COVID who is vaccinated. So you can still, there's breakout cases all over the place with Delta. Okay. All right. Chapter 8, hypothesis test. A hypothesis test is a test to see if your sample is unusual or not. Right? So if it's in here, we're like, okay, that's usual. If you get something way out there, that's when we say, we got something unusual. The null hypothesis says that my mean is the same as everybody else's mean. So the null hypothesis says that I am right here, where everybody else is. If I get anything inside of here, I don't dispute that. I'm like, well, maybe. This is all reasonable, right? It could vary. It's going to vary a little bit around the mean. But if I get something way out here that's really unusual, then I'm going to say the null hypothesis is not true. I'm not there. I must be something further this direction. So that's the idea. If you get something unusual, if your sample is unusual, then the null hypothesis can't be, you're saying you don't think it's true. In other words, remember we got like 5 black cards in a row? And we're like, we don't think that deck has 50% red cards because we got something super unusual. Everybody understand that concept? So you're going to say that we don't think that the deck has 50% red cards. All right, so that's the basic concept of the null hypothesis. If you wrap your head around that, the rest of it's pretty smooth. Okay. How about Lauren? Go and read for me.
The null hypothesis, symbolized by H0, is the statistical hypothesis that states that there is no difference between 2 parameters. The alternative hypothesis, denoted by H1 or HA, is the statement that the parameter has a value that somehow differs from the null hypothesis. The symbolic form of the alternative hypothesis must be one of these symbols, greater than, less than, or not equal to.
Perfect. The null hypothesis, null again means 0 or none, right? So 0 difference. If there's zero difference between you and somebody else, that means you're the same, you're equal. So the null hypothesis is always, always, always equals. So it's always, always, always no difference, 0 difference. Which means that the alternative hypothesis has to be some other symbol, right? Something besides equals, greater than, less than, or not equal to. All right, so the following claim. The claim is the mean. So that's going to be mu. Don't just put, I'll talk about it in a second. The mean is equals 105. So H naught is mu equals 105. Do not put this. That doesn't mean anything. H naught, my hypothesis is equals 105. What equals 105? Right? You have to say what equals 105. So your hypothesis should always start with mu or p in these units, in these chapters here. So make sure you don't leave out the mu. The mean is 105. So think of the H naught as sort of being like a label. It's just saying like name, colon, and then you write whatever your name is. Here it's saying the hypothesis is, and you write what the hypothesis is. The mean is equal to 105. Is that my claim? Is H naught my claim? What's my claim?
H naught
Equals 105. Okay, so is H naught my claim?
Yes.
Yes. So then H1 becomes the opposite of my claim. What's the opposite of equals 105?
Not equal.
Equals 105. Remember, the number stays the same for all of them. Whatever your claim is, that's the same number you use there, there, and there. What changes is the symbol. Greater than, less than, not equal to, equal to. So the only thing that varies between them is the sign, is the symbol, right? Whether it's greater than, less than, or equal to, or that sort of thing. Is this one-tailed or two-tailed?
Two-tailed.
Two-tailed. Remember, not equal to. How can I be not equal to? I can be less than, or I can be greater than. I can be left-tailed or right-tailed. So it's two-tailed. Number 2. Let's see. He believes his stuff, his levels, will be higher than 65. So is this going to be oxygen levels? Is that a number or is that a yes, no? So if someone said, what's your oxygen level? Are you going to say yes? Or you're going to say a number? Does that make sense? You wouldn't be like, what's your oxygen level? No. That makes no sense, right? So this is going to be a number, which means that it's going to be a mean. Does that make any sense for folks? Proportions come from yes, no questions, right? Do you like bananas? Do you like bananas?
No.
Do you like bananas?
Yeah.
Do you like bananas? Do you like bananas? So then we'll have a proportion. Proportion of people who like bananas versus, but my data is yeses and nos. Means your data is numbers. So here, this is going to be a mean. So again, what's my claim? His oxygen level says mean is going to be what? Greater than 65. Higher. Greater than 65. If you can't remember how it goes, remember the little fish? He ate the smaller one because the smaller one's easier to catch. The bigger one is still out there. He's trying to catch him. So mu is greater than 65. My H is always, always, always what?
Equals.
Equals. So mu is equal to 65. Is my claim the same as H naught?
No.
No. My claim is greater than. This is equal. So that means that H1 has to become my claim, because one of them has to be my claim. So if my claim is not the equals one, then that means that this one, I have to make that one my claim. So then my H1 is, mu is, yep, greater than 65. Good? Okay. Is this one-tailed or two-tailed?
One-tailed.
One-tailed. Yep, greater than is just right-tailed. Terrific. Then, this was on your sheet. We also covered this. Remember, when the mean is known, we're never going to cover that, so cross that out. If it's a proportion, remember, easy peasy, proportion, P, Z table, Z score. So you'll see it's a Z. The test statistic is a Z-score. It's your p hat, what you got from your sample, minus the p, what you expect to get. In other words, what's in your claim, divided by square root of pq over n. Remember, we expect to get what's in our claim. So we should be using p and q from our claim for that underneath the square root. Because we're assuming the h naught's true. We should pull that from the null hypothesis. For our mean, what do we use for our mean? Which distribution? Z or T? Which one?
T.
T. Remember mean Mr. T. Mr. T is really mean looking. Mean Mr. T means you use a T distribution. So this would be a T score. How do you find it? You take what you got from your sample, your x bar, subtract what you expected to get from your claim, mu, and divide it by the standard deviation, s over square root of n. Okay, so standard deviation for a sample. All right, here was your quiz. Let's see. Is this a proportion or a mean?
Proportion.
How do I know?
It doesn't say mean.
Yeah, it doesn't say mean or average,
It says
and it says proportion. Perfect. Good. So, so then my claim. What's my claim first of all?
A proportion of piece of yellow pods is equal to 25%.
Yeah, the proportion is equal to 0.25. So if p is equal to 0.25, that's my claim. Everybody on board? All right. The one that's in your claim, that's your p. So here, I need to find my test stat. I'm gonna write down my claim while I'm at it, just so I get I'm kind of used to this sort of stuff. Maybe I'll use 25%, and I'll tell you why later. 25%. My H naught is the same thing. It's always equals. So that's P is equal to 25%. My H1 then would be what?
Doesn't.
Yep. Does not equal. Perfect. All right, great. So then my test stat is, let's see, it was, now look, it's proportion. So the proportions, it says p hat minus p over square root of pq over n. Which means I need to find my p hat. Okay, so sample, p hat's your sample proportion. So my sample includes 540 p's, that's my n. The 125 of them having yellow pods. So remember, for a proportion, either you're going to be given a percentage, right, for your p hat, and so you grab the percentage, or you'll be giving a number of yeses, number of people who said yes, and you have to figure out what your p hat is. So here, did they give me a percentage? Now, how do you know it's a percentage when you see a percentage? What was that? Yeah, it'll literally have the percentage sign on it. There's no percentage sign here. Everybody see that? Under samples, there's no percentage sign under samples. It didn't say 540 and 12% of them. It doesn't say that. It just says 128 of the pods. So that means that 128 of them said yes. They said, yes, I'm a yellow pod. That was basically what they said, right? Kind of see them. 128 pods said yes, they're yellow. So the percentage of yellow pods would be 128 over 540. That's my p hat. Did I say that right? I said that right. And you folks got 0.237, I believe, yeah? Great. So this is going to be 0.237 minus p, which is 0.25. And again, use 3 sig figs, 3 decimal places. So 0.237, not 0.24, or else you're going to cut off. That's like 10% difference. You're slicing off if you round it to 2 decimal places. You slice off a chunk. It's significant. If you think 10% is not significant, then give me 10% of your paycheck, and we'll see how that works for you. Okay, good deal. And then P is 0.25. Q, remember, is 1 minus 0.25. So if I buy something for 25 cents and I give them $1, what's my change? 75 cents. So that's my Q. Yeah, always use, you guys are so familiar with money. Use money because remember, did we talk about this before? When you're learning new things, your brain, your working memory can hold up to 3 things in your brain if it's new. If it's old stuff you're really familiar with, you can hold like 7 things. Like when you're driving, you can do a couple of things while you're driving now because you're used to driving. And that's like kind of one thing. But when you first learn how to drive, you can only barely just focus on driving, you know what I'm saying? So, because it's familiar. So the more familiar you are with things, if you can hold more of them in your head at one time. So anytime you take a new concept and put it in terms that are familiar to you, then that will let your working memory spend more time on the new stuff and not be like working with things that are confusing already. Yeah. So, all right. So money's good, and you end up getting.
Oh, on top, sorry.
0.013 on top. Yeah, and then yes, so definitely find the top first, find the bottom first, give yourself lots of decimal places. Like someone said for the homework, you need like 5 decimal places so that you don't get marked off on the homework. At least 4. And then you can work from the inside out. So whenever you're doing math stuff, you do from the inside out. So inside here first, 0.25 times 0.75 divided by 540. So I'm going to do 0.25 times 0.75 divided by 540. And instead of this messy sort of e negative whatever, I don't even want to mess with that. I want to square root that. So I'm going to raise that to the 1/2 power. So I like to do it that way. So above the division sign is that raising to the power thing. And so raising to the 1/2 power, that's a square root. What's 1/2 as a decimal? 0.5. Raise it to the 0.5. And I get 0.0186. So now I'm going to divide those. And you will get 0.699. Oh, negative, sorry. Wait, this is negative. Or negative 0.70, depending on whether you want to use. So I like 3 sig figs, but if you're doing z-scores, you can just use 2 if you like. That's fine. 2 or 3 is fine. Either one's good. Okay. Great. So